Hi. So next let's discuss a deck of cards. So we have a 52 standard deck of cards. So we're not going to talk about wild cards or anything like that. They're just going to be a standard ace through king, and where the ace is counted as 1, not 11, because we're not playing blackjack. And then we have 4 suits, and in the 4 suits we have a spade and the club, which are both black, and hearts and diamonds, which are red. So you can go ahead and use this as a good reference to the cards because there's a lot of card games and problems in your homework with the cards, so it's nice to have a good reference. Okay, and so there are 13 cards in each suit. So each suit has 13 cards, and each face has 4 of each. So in this case, we have 13 cards in each row, which is the same suit. And then of the face, we have orange, 4 each. So there are 4 aces, 1 of each suit, and 13 cards of each of the suit from numbered ace through a king. Okay, and so that's really what we need to know because there are 52 cards in the deck, and so that's how we get 52 cards. We have 13 in each suit, times 4 of each is 50, 13 times 4 is 52. So let's just say that Bucky has a deck of standard 52 cards and wants his friend Satchel to draw a card. After Satchel draws a card, he puts it back in the deck. What is the probability of Satchel drawing an ace from the deck of 52 cards, and what's this say about the probability of drawing just one type of card? Well, if we go ahead and take a look here, we would see that the event is Satchel drawing a what? An ace. But notice that it could have been an ace, a king, a queen. We could have asked for any of the faces. And so the probability of drawing an ace is equal to the number of ways that Satchel could draw an ace over the total number of outcomes. Okay, so what is this? Well, how many aces do I have in the deck? So let's just look at our deck. Well, we have 4 aces. Okay, so there's 4 different ways I could draw an ace. Out of how many possible cards do I have to pick from? If I go into a deck of 52, how many cards in there do I have to pick from? Well, any one of these. So it's out of 52. And this means that this reduces to 1/13. Okay, so what does this say about drawing one type of card? Well, in general, drawing any one type of card from a deck of 52 the probability is 1/13. Because I could, what if I asked for a 7? There's still 4 sevens, 10, 4 tens, 4 queens, 4 twos. So I could have asked for any one of them, and it would be any face. There's 4 of them out of 52. So the probability of drawing any one type of card is going to be 1/13 no matter what. So let's look at this a little bit differently. Let's look at a more applicable problem. So a survey was taken of drivers admitting to running a red light in the last year. The number of yes responses was 500 and the number of no responses was 213. Find the probability that if a person is chosen at random, he or she has run a red light in the last year. So the probability, so what is the event? Let's start there. So the event is whether or not this person ran a red light. Okay, so the probability of this event occurring is the number of ways a person runs a red light out of how many total outcomes. Now I keep saying outcomes, but really in this case, I'm talking about people, so it'll be total people. In the previous case with Satchel and the cards, right? I was talking about cards, and so the outcomes would be how many cards I have. So it just means how many total things in your sample space, right? So the probability of a person running a red light is the number of ways it could run a red light. So let's look at that. So how many people admitted to running a red light? So the number of yes responses was 500. So this means that it was 500 out of how many total outcomes? Well, how many people did I survey? Well, I didn't survey 500, right? Only 500 out of everybody I surveyed said they ran a red light. So how many people did I survey? How many people said no, they didn't? 213, right? And so the number of people that I sampled was the 500 plus the 213 no responses. So I'm just going to put like 500 plus 213 in the denominator, which is really just 500 over 713. Okay, so that's the probability here. But in real life, when we talk in conversation about these chances of running a red light, we usually use a decimal form. So let me show you the approximate form where we would just go to our calculator and put in 500 divided by 713. And this is probability, so I probably want to round a little bit because of a percentage. So I'll put 0.7013, which is 70.13%. So we could say something like about 70% of people said they had admitted to running a red light last year. And that's how we would talk in conversation. I wouldn't say 500 divided by 713 is the number of, I'm not a robot, we're people and we want to talk like as people. So I would just say in conversation, oh yeah, like I read that like about 70% admitted to running a red light last year. Isn't that crazy? And so we just want to make sure that we read the problem, and if it specifies to leave in a fraction, we will. And if it specifies that we round to a percentage, we will. And if we round to a decimal, we will. So we just want to pay attention to those things. But when we ask to interpret and have a conversation, we always tend to like to use percentages. Okay, so what are the probability rules? That the impossible event is 0 and that a certain event is 1. So when you hear people say, well, that's impossible, that's to people, that's just a word of impossible, right? That, oh, that's never going to happen. But to mathematicians or statisticians, where like computation probability is 0, like we automatically think of it in terms of a chance of a likelihood of an event occurring, and that would be 0. And so if we say, oh well, that's certain, you're certain of that, I'm certain of it, that means that your probability is 100%, that you have a chance of a likelihood of an event occurring to be 100%. And so the 0 and 1 come from 0% and the 1 is 100%, right? And so all probabilities have to lie between 0 and 1. And if it is 0, then you say that it's impossible. And if it's certain, you say it's 1. So, for example, what is the probability of tossing a heads or a tail on a coin? Well, heads or tails, well, you're going to do that. That's what it's going to land on. I'm certain that's going to happen. That's 100%. What if I asked you on the 6-sided die, what is the probability of tossing or rolling a 7? You're like, well, there's not a 7 on a 6-sided die. Well, then that's impossible, right? And that probability is 0. So you can see that there are certain times we can think of when something would be certain and something would be impossible.